Okay, so here's a little harder problem. So we still want to find the derivative of f of x equals 1 over x, and we want to use it using the definition of the derivative. So using the same definition. Okay, so I know that f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. Okay, so reminder, we do still know what f of x is. So this thing, I'm going to call it blue, is going to go in here. Okay, so that's easy. However, the one in green, we still need to know what that is. So I'm going to write it over here, f of x plus h. Well, that, all I got to do is just plug in x plus h wherever I see an x. So here's an x, I'm going to plug in the x plus h there. So now I know what this is. It's just going to be that. Okay, so let me go ahead and plug everything in. So I'm going to have the limit as h goes to 0 of 1 over x plus h minus 1 over x, all divided by h. Okay, now here's the difficulty in it. The difficulty is that now, what do we do with this numerator? So this is kind of like adding or subtracting two different fractions and knowing that we need to find the least common denominator between both of them. Now this one has an x, this one has an x plus h. In order to find the least common denominator, I need to make sure that I multiply both rationals by the same value in order for me to have the same denominator. So for example, this one already has an x, all this is missing is an x plus h. But whatever I do to this side, on the denominator, I also have to do to the numerator. So I also have to have an x plus h here. Now the other one already has an x plus h, okay? So that one's good. Now all I gotta do is just multiply by an x, because this one had an x, so now this one also has to have an x. Okay, so now what I'm gonna have in the end, okay, so this is still gonna be the limit as h goes to 0. So the top is gonna be x over x plus h times x. So I'm gonna write it like this, x times x plus h. So all I just did was I just swapped these two on the new denominator. On the top, I'm gonna have x plus h, and on the bottom, I'm gonna have x plus h, and then all divided by h. Okay. So now the reason why I did that is now I can combine the numerators together. Okay, so I'm going to have the limit as h goes to 0. So now I have all of this over h. Now over here I have a fraction. Okay, so this negative is going to be distributed to both of these things. Okay, so what I'm going to have x minus h divided by x plus h. Okay, that's what I have. If you need to see an intermediate step, this is all that we did. We just combined the fractions by saying x minus x plus h divided by x plus h, okay, all over h. And then after that, I just distributed the negative over so that you get that, okay? All right, and now notice that my x's are not going to go away. This goes away and this goes away. Okay, so what I'm going to get now, I'm going to get the limit as h goes to 0 of negative h divided by x plus h divided by h. Okay, now how do you solve this? Okay, now this is a complex fraction. Okay, so the way that you can do it this way, limit as h goes to 0. So here's the numerator. This is negative h divided by x plus h. And now this is the denominator. This fraction tells me that it's being divided. So this is divided by h. Now when we're dividing fractions like this, remember that we are going to do the following. Okay, so we're going to keep the first one, this negative h over x plus h. And now what I'm going to do, this changed to multiplication, and now I'm going to flip the h to 1 over h. And now you see that the h's are just going to cancel out. And what I'm left with is just the limit as h goes to 0 of the negative. Remember that there was a negative there, negative 1 over x plus h. All I got to do is just plug in 0 in there. I'm going to get negative 1 over x plus 0. This is going to give me negative 1 over x times x, which in turn is going to give me negative 1 over x squared. Oops, oh, I ran out of space. I'm going to write it over here. This is going to give me -1 over x squared. And this thing is the derivative of that function. Okay? So it was a little bit of a longer process, but it's still doable. Okay?